In these lessons, we used Autodesk Inventor's motion simulation to determine the maximum force required to rotate the gears, and using that value, calculate the torque for the motor. A simplified version of the robot was modeled, and a motion constraint was added between the pitch circles on the gears. These are the imaginary cylinders where the two gears contact. To locate the load on the arm, a point was created. In the dynamic simulation environment, the assembly is converted into grounded or mobile groups, and assembly constraints are converted to joints. For this simulation, a rolling cylinder-on-cylinder joint was added. A review of the axes shows the force along the x-axis should be determined. The simulation was run, and the data from the output grapher was reviewed to determine the maximum force along the x-axis. Using this value, the torque was calculated by multiplying the force times the radius of the small gear. The values were compared to the specifications for the VEX motor. The conclusion is that a single motor design is acceptable. Now that you've seen one example of using Autodesk Inventor's motion simulation, it is your turn to calculate the maximum torque required to raise the arm on your robot design.